Design and development of electric vehicle two-wheeler. Introduction. The architecture of an electric vehicle, EV, two-wheeler system can vary depending on the specific design and manufacturer. However, here's a general overview of the key components and their interactions in an EV two-wheeler system. Battery pack, electric motor, motor controller, vehicle control unit, fuel battery management system, BMS power electronics, user controls, instrument cluster, regenerative braking system, communication interfaces. It involves several steps that encompass concept development, engineering, prototyping, testing, and production planning. Here's a detailed overview of the typical stages involved. Concept development. Identify the target market, customer needs, and market trends. Conduct market research and gather insights to determine the product's features, performance, and price range. Develop a design concept, considering factors such as aesthetics, functionality, and market positioning. Design and engineering. Create detailed design specifications based on the concept, incorporating considerations like aerodynamics, weight distribution, and structural integrity. Design the chassis, body, suspension, drivetrain, and other key components. Use computer-aided design, CAD, software to generate 3D models and perform virtual simulations and analysis, including structural, thermal, and fluid dynamics. Optimize the design to meet performance, safety, and regulatory requirements. Battery and powertrain development. Select the appropriate battery technology, capacity, and configuration based on performance goals, range requirements, and cost considerations. Design and integrate the battery pack, motor, motor controller, and power electronics into the vehicle. Perform system-level simulations and analysis to optimize powertrain efficiency and thermal management. Prototype development. Build a functional prototype based on the finalized design and engineering specifications. Source and integrate components from various suppliers. Conduct extensive testing and validation, including performance testing, durability testing, and safety testing. Refine the design and make necessary adjustments based on the results of prototype testing. Regulatory compliance. Ensure the vehicle design complies with relevant safety and emissions regulations and standards. Perform necessary tests and obtain certifications from regulatory bodies. Address any design modifications or improvements required for compliance. Manufacturing process planning. Develop a comprehensive manufacturing plan, including processes for component fabrication, assembly, quality control, and testing. Identify manufacturing equipment and machinery requirements. Define production line layout and workflow, considering efficiency, ergonomics, and safety. Supply chain management. Establish partnerships with suppliers for sourcing raw materials, components, and subsystems. Ensure the availability and quality of components to meet production demand. Implement inventory management systems to optimize supply chain efficiency. Tooling and production. Develop production tooling, including molds, dies, jigs, and fixtures. Set up the production line and initiate small-scale production runs. Implement quality control processes and inspection procedures at each production stage. Monitor and refine the manufacturing processes to improve efficiency and quality. Post-production testing and validation. Conduct rigorous testing on finished vehicles to ensure they meet performance, safety, and quality standards. Perform functional testing, durability testing, and environmental testing. Address any issues or defects identified during testing and make necessary improvements. Launch and market entry. Plan the launch of the EV2W, including marketing campaigns, distribution strategies, and after-sales service. Establish sales and service networks. Monitor customer feedback and make continuous improvements based on user experience. Conclusion. It's important to note that the design and development stages may overlap, and iterations and refinements are common throughout the process. Additionally, regulatory compliance requirements may vary depending on the target market and specific regulations governing electric vehicles.